Hello, in this video we're going to look into Le Chatelier principle. In the previous video we had discussed about position of equilibrium and we had looked into the meaning of this particular term, which is used to describe the relative amounts of a reactant and product in a mixture. So if the position of equilibrium is at the center of a reaction mixture, it indicates that the reaction includes or contains equal amount of the reactant and product. Whereas if the position of equilibrium is to the right hand side, then it indicates it has got more products. If the position of equilibrium lies to the left hand side, it indicates the reaction mixture has got more reactants. Now the position of equilibrium can be changed. It can be changed by changing certain factors. And all of this relies on a particular principle which determines the way the position of equilibrium will move. And I'm referring to Le Chatelier principle. So before we go any further, we need to understand the meaning of the word or the meaning of this particular principle. Le Chatelier principle, in reality, if you think about it, it treats a reaction like a rebellious teenager. Those who've got rebellious teenagers at home, you would know in order to get something done, you've got to use reverse psychology. In the same way, in chemistry, if you want the reaction to go in a particular direction, you've got to indicate that you want it to go in the opposite direction. So if you want more of C and D to be formed, you want more of this to be formed, you've got to act as if you are going to want more of this by increasing the amount of A and B. So the reaction thinks you want A and B and it will start to produce more C and D. It's as simple as that. If you want, you can also take out C and D. So the reaction thinks you don't want C and D and it will start to produce more C and D. So that was quite a crude analogy. But in reality, it's just that if you change the conditions of a reversible reaction, reaction would just try to counteract that change. It would try to oppose that change. And the position of equilibrium would move to either to the left or to the right hand side of that particular reaction. So you can either change certain factors. The factors are concentration, pressure, and temperature. So the rest of the video, we're going to look into the impact of these concentrations on the position of equilibrium. Let's look into the first factor, that is effect of changing the concentration. When you change the concentration, again, the same thing would happen. The reaction would move in the direction to counteract that particular change. Let's look into this. Let's use this particular reaction as an analogy. We've got chromate ions, which are yellow in color, dichromate ions, which are orange, and this is a reversible reaction which has achieved equilibrium. So if you take a bottle of dichromate solution, it will look kind of yellowish orange. So more of orange because dichromate ions would be more in that. But remember that that particular bottle has got both ions, but you don't see yellow because that's masked by the more predominant color, which is orange. Now, what happens when you add an alkali to this solution? Now, you've got to remember an alkali contains OH minus. So that's your alkali. Alkali is going to react with the acid in the solution and it would produce water. We've got water here. So that means when you add alkali, you are using up more of H+. So if acid is being used up, therefore the concentration of H+ is decreased. That means the reaction would try to oppose that change by producing more of H+. Therefore, the position of equilibrium will move to the reactant side. Reactant side, if you use your hands, it's on your left hand side. So the position of equilibrium moves to the left hand side. It produces more of H+ because it thinks that you're using it up. It tries to oppose the change by increasing the concentration of H+. Therefore, the color change that you see is from orange to yellow. Okay, so that's the summary of that particular change. So now we take a look at what would happen to that equilibrium if you add an acid. Now you got to remember that the acid is H+. So if you add H+, that means H+ concentration has increased. If the H+ concentration has increased, the reaction will try to oppose that change. It will try to reduce that increase. That means it will use this H+ up to move the reaction in the forward direction. Therefore, more of dichromate will be formed by using up H+. Therefore, you can say that the position of equilibrium will move to the product side. Now product is on your right hand side, so it will move to the right hand side. It will form more product, so it's going to form more of Cr2O72 minus. The color of that is orange, therefore the solution will turn into or deeper orange color. So you could again keep adding H plus OH minus, and it would look like a traffic light experiment, and it's one of the very fun experiments to actually see as a demo or to try it out. We move on to the second factor that can change the position of equilibrium. The factor that we're going to look here is pressure. Now pressure is a slightly tricky factor to visualize, because when you look at the equation, you will not be able to identify the pressure straight away. In order to do that, you've got to think about pressure in terms of moles of gas. The first key point is it has to be in a gaseous medium. So think about moles of gas here. Gas particles are colliding with the sides of the container, and therefore they are the only ones that exert pressure. The more crowded the gas particles, higher the pressure. So therefore, if you want to increase the pressure, you really want more and more particles in that particular medium. So what I'm trying to say here is, if the pressure is high, that means it indicates that the system has got very crowded particles. So let's look into this particular reaction, and let's first of all discuss about the moles of gas. Here you have got, first thing you've got to do is you've got to find out how many gas moles are here. So we look at the numbers that are written in front of the reactant. So we just say that is 1, because it's gas, that is gas. So 1 plus 2, on the left hand side I've got 3 gas moles. On the right hand side, that's 1, so I've got 1 mole of gas. So this side, as I mentioned earlier, higher pressure means more crowd. You've got 3 moles here, this side only has got 1 mole. Because this is more crowded, this has got higher pressure. Less gas moles, this has got low pressure. Now what would happen when you increase the pressure? So in this particular reaction, when you increase the pressure, remember that the position of equilibrium will go to a side to oppose the change. Now you're increasing the pressure, so it will try to go to the side which has got low pressure. So you've got to look at the reaction, figure out the gas moles, and then decide which side is at low pressure, and then you would say that the position of equilibrium will move to the, in this case, it will move to the right hand side. So you will get more amount of methanol, because product is methanol. So what would be the effect on the yield of methanol? So you would say it will increase, and you will have to explain it in terms of that the position of equilibrium has moved to the right hand side to oppose the increase in pressure, and because the right hand side has got less number of gaseous moles. Do remember to refer to the gas moles, otherwise you will end up losing marks in the exam. What would happen if I decrease the pressure for the same reaction? So we use the same steps. You could pause the video now and find out the answer. If you have paused the video and found the answer, then this is what you would have done. You would have had first figured out the number of gas moles on both sides. So on this side I've got 1 mole, 2 moles. On this side I've got 1 mole. So total number of moles here is 3. So this has got low pressure. This has got high pressure. So if I decrease the pressure, then position of equilibrium will move to the side with higher pressure. So that would be your first point. It would move to the side with higher pressure to oppose the change, and therefore it would move to the left-hand side, and therefore the amount of methanol produced would decrease. What happens in this particular equation? You could pause the video and take a look. And if you pause the video, you would have done the same steps as before. You would have found the number of gas moles, 1 mole, 1 mole. On the left-hand side, you've got 2 moles of gas. On the right-hand side, you've got 2 moles of gas as well. Now, if you decrease the pressure, the reaction would go to the side with a higher pressure, but because both sides have got equal number of gas moles, therefore both sides have got same pressure. Both sides have same pressure. Therefore, the position of equilibrium will not move to either direction. So that was a tricky question, but you got to be vigilant that you only spot the reaction which is, only pick the reactants and products which are in the gaseous state. Now let's move on to the third factor, which is temperature. So for temperature, you would have to look into whether the reaction is exothermic or endothermic. At GCSE level, you will be given the reaction as energy is released, heat released. So you could have heat released given out, or it would be mentioned exothermic, or it might be given, the value might be given, let's say 100 kilojoules. At A level, you might be given delta H value 100 kilojoule per mole. So any of these factors, you can look at them and figure out that the products, the forward reaction, so if this side is given as negative or heat is released, that means that the forward reaction is exothermic. And if the forward reaction is exothermic, you could just go and write on top of the products, you would say this side is the hotter side. And therefore, the reverse reaction is endothermic. So that means the reverse reaction is the cooler side. So you've got to make this clear at the beginning. So that if the forward reaction is exothermic, the reverse reaction will then be endothermic. So do this analysis first before you start to think about which direction the position of equilibrium will move towards. Let's try out this question now. So you've got this reaction, you've got to figure out what's going to happen if, let's say, we are increasing the temperature. So if the temperature increases, what happens? You could pause the video and try it out. And if you had paused the video and you've just arrived back to this video, let's see what you would have done. So as mentioned earlier, you would have looked at the negative sign and you would have said, okay, that indicates that the forward reaction is exothermic. If the forward reaction is exothermic, that means this side is hot. And the reverse reaction is going to be endothermic. That means that is the cooler side, or that's cold. If I increase the temperature, then the position of equilibrium will try to oppose the change. So it opposes the change. You're trying to increase the temperature. That means the position of equilibrium will move to the side which is colder. And in this case, that is your left-hand side. So you will get less ammonia being formed. So if you increase the temperature, the reaction will oppose the change by trying to